Good day, students. Today's topic is today's first topic is the properties and the graph of the Laplace function. The properties and the graph of the Laplace function. Laplace function. First, remember the expression of the Laplace function by means of error integral phi capital bar of x. It is notation of the Laplace function is equal to 1 second multiplied by phi of x over square root of 2. Phi capital is the error integral. Then investigate the properties of the Laplace function according to the properties of the error integral. First property, the value of the Laplace function at 0 is also 0. We can prove this fact. Phi bar of 0 is equal to substitute 0 instead of x in the argument of the error integral. Phi of 0 over square root of 2, it is 0, 1 second of phi at 0, and you know that the phi at 0 is 0, therefore we will obtain 1 second multiplied by 0 is 0. That is phi bar of 0 is 0. It is our first result. And it means the graph of the Laplace function is passing through the origin. Second, investigate whether the Laplace function is even or odd function. Therefore, we must find the value, the expression of the Laplace function at minus x. Phi bar at minus x is equal to, then substitute minus x instead of x in this formula. 1 second multiplied by phi capital of minus x over square root of 2. And already it is known that the error integral is odd function, and therefore we can take the negative sign out of the function symbol. Therefore we will have minus 1 second multiplied by phi of x over square root of 2, and it is the expression of the Laplace function, and we will have minus phi bar of x. That is phi bar of minus x is equal to minus phi bar of x. It is our second result. That is, the Laplace function is odd function, and it means its graph is symmetric with respect to origin. It means if turn the graph of the Laplace function with respect to origin, then we will obtain the identical the previous graph. Third point. In this point, investigate whether the Laplace function is increasing or the decreasing function. For this, find the derivative of the Laplace function, and it is known that if derivative of function is positive, that is, this function is increasing, and if derivative of this function is negative, that is, the given function is decreasing one. find the derivative of this function phi bar prime of x is equal to, and then we must find the derivative of this function. 1 second multiplied by phi of x over square root of 2 prime. Here 1 second is the constant factor, and it is can be taken out of the derivative symbol. 1 second multiplied by phi capital prime of x over square root of 2, and it is known that the derivative of the Euler integral is positive, and it means the derivative of Laplace function is also positive, and that is Laplace function is increasing function, increases. Phi bar of x, phi bar of y increases. First point, investigate the behavior of the Laplace function at plus infinity. For this, find the limit of this function at plus infinity, at positive infinity. Limit phi bar of x at plus infinity when x tends to plus infinity. That is limit when x tends to plus infinity of 1 second multiplied by phi at x over square root of 2. Then we can take 1 second out of the limit symbol. Then 1 second multiplied by limit when x tends to plus infinity of phi of x over square root of 2. Then substitute plus infinity instead of x. If here plus infinity over square root of 2 will give also plus infinity, and we'll have 1 second multiplied by phi of plus infinity, and we know that the limit of Euler integral at plus infinity is unit. 1 second multiplied by unit is 1 second. That is limit of f bar of x when x tends to plus infinity is 1 second. So I think it is our fourth result, and it means the line y equals 1 second is the horizontal asymptote. And finally, investigate the value, the behavior of the Laplace function at minus infinity. Fifth property, find limit f bar of x at when x tends to minus infinity. Limit when of f bar of x when x tends to minus infinity. Then write limit. Then write the expression of Laplace function. 1 second multiplied by phi at x over square root of 2. Then take 1 second out of the limit symbol equals 1 second multiplied by limit when x tends to minus infinity. Of phi capital of x over square root of 2, then equals substitute minus infinity instead of x minus infinity divided by square root of 2 will give minus infinity. 1 second of multiplied by phi of minus infinity, and we know that the limit of error integral at minus infinity is minus 1. 1 second multiplied by minus infinity is equal to minus 1 second. 1 second. It is our last result. Limit of phi bar of x when x tends to minus infinity is minus 1 second. 1 second. It means the line y is y equals minus 1 second is another horizontal asymptote. Then construct the graph of the Laplace function according to its properties. Y equals 1 second, y equals minus 1 second, it is 1 second, it is minus 1 second, here minus infinity, here plus infinity, and then construct the graph of Laplace function graph. Y equals phi bar of x. Phi bar of x. According to the first property, our function, that is Laplace function at 0 is 0. It means the graph must be passing through must pass through the origin. According to the to the second property, our function is odd function. It means this function is symmetric with respect to origin, and it means if turn the graph of Laplace function by 180 degrees with respect to origin, then we will obtain the identical graph, the previous graph. And according to the third property, our function is odd function. Our function is increasing function. You see that the Laplace function increases. According to the fourth property, at plus infinity, the graph, our function tends to 1 second, and that is the graph tends to the straight line y equals 1 second, and it means this line is the horizontal asymptote. And according to the last property, our function at minus infinity tends to minus 1 second. It means the graph of Laplace function is tending to the line y equals minus 1 second, and it means the line y equals minus 1 second is another horizontal asymptote. The next topic is the median deviation. the median deviation, and its connection, with the standard deviation. The median deviation is denoted by capital Latin letter E or capital Greek letter epsilon, also epsilon. And according to its definition, the median deviation is such a value for which the probability that continuous random variable with a normal distributive density will be situated in the symmetric interval A minus E capital, A plus E capital is equal to 1 second. It is definition of median deviation. That is P capital that contains random variable is situated between A minus E and A plus E. Is 1 second. It is definition of the Laplace. Definition of the median deviation. And also, you know the formula, expressing the probability that continuous random variable will be situated inside the symmetric interval is expressed by means of definite integral, or P that A minus E is less than x is less than A plus E is equal to, by means of error integral, phi of L over sigma square root of 2. Here in the right part the A is absent, and it means this probability doesn't depend on symmetry center A. Then equalize the right parts. Phi capital of L over sigma square root of 2 is 1 second. And according to the table of the error integral values, the corresponding argument is equal to 0.48, and it is denoted by rho. Greek letter rho. That is L over sigma square root of 2 is rho, where rho is equal, rho is approximately equals 0.48. Here rho is constant. Then find here find sigma from this formula, and then continue our lesson. But here the radius of the symmetric interval is E capital, because we consider the interval A minus from A minus E to A plus E, and here we must substitute E capital instead of L. That is E capital over sigma square root of 2 is rho. Then from here we can obtain the expression for sigma. Sigma is equal to E over rho square root of 2. It is a formula of connection between E and sigma. Here sigma is standard deviation, and E is the median deviation. Then remember the formula of probability of following the continuous random variable into the symmetric interval, A minus L and A plus L. P that A minus L is less than x is less than A plus L is phi capital of L over sigma square root of 2. Then substitute this expression instead of sigma in the argument of the error integral equals phi capital of L over E divided by rho square root of 2 multiplied by square root of 2. Then we can simplify by square root of 2, and rho will transfer into the numerator, and then we will obtain phi capital of rho L over E. Finally, we will obtain this formula P that A minus A is less than x is less than A plus L is phi of rho multiplied by L over E. It is very important formula. Then continue our lesson, and we introduce the next function, the reduced Laplace function. Reduced Laplace function is denoted by the following letter. Right term, the topic, the reduced Laplace function. Reduced Laplace function. Laplace function is denoted as phi tilde. The symbol is named tilde of x. Tilde. Tilde equals phi of rho x. the reduced Laplace function is expressed by means of the R integral with support this formula. And therefore we can rewrite this formula of probability. P of L minus L is less than X is less than A plus L. L is equal to phi tilde of A over E capital or epsilon capital. Then continue. Right, new topic, 4E rule. 4E rule. Take L equals 4E and then substitute 4E instead of L in this formula. P that A minus 4E is less than X is less than A plus 4E. 4E is equal to phi tilde of 4E over E. Here we can simplify by E, then we will obtain phi tilde of 4. And according to the table of the reduced Laplace function values, it is approximately is equal to unit, or is equal to approximately 0.99, and it is approximately is unit. That is P that X will be situated between A minus 4E and A plus 4E is approximately equal unit. This formula is named the 4E rule. And we know that the probability of following the continuous random variable with the normal distributive density into the symmetric integral doesn't depend on the symmetry center A, and here we can take A equals 0. That is P that continuous random variable will be situated between minus 4E and simply 4E is approximately equal to unit. Then finally go to the last topic named the probability disperse scale. The probability dispersion scale. Construct the scale. construct the scale. First, construct the graph of the normal distributive density. Normal distributive density. Minus infinity, here plus infinity. Take here E, then 2E, then 3E, then 4E, minus E, then minus 2E, then minus 3E, and finally minus 4E. It is graph of the normal distributive density, and in this formula here the symmetry center is 0, that is the formula of normal distributive density will be written in the following form: 1 over sigma square root of 2 over e to minus x squared over 2 sigma squared. According to the condition of median deviation, the probability that the continuous random variable with a normal distributive density will be situated in the interval from minus e to e is 0.5, is 1 second. And also you know that here probabilities are equal to the areas of these regions, and area of these region is 1 second or 0.5, but these areas are mutually equal. Therefore it is according to the definition of median deviation is exactly equal to 0.25, exactly equal to 0.25. And by means of with the help of the table of the reduced Laplace function values, this area is approximately 0.16. It means the probability that continuous random variable with a normal distributed density will be situated in the interval e to e is approximately equal to 0.16. Then this area is approximately 0.07, and it is approximately 0.02. And also here approximately is equal to 0.16, approximately is equal to 0.07, and approximately 0.02. And you can see that the probability that continuous random variable with a normal distributive density will be situated in the interval minus 4e is approximately unit, because if summarized these all probability, we will obtain 1. 0.25 plus 0.16 plus 0.07, 0.02 is 0.5, and twice it is unit. And therefore the probability that continuous random variable will be situated in the interval outside the interval minus 4e is approximately is 0. Now our lesson ended, dear students. meet you soon. Goodbye, students.